Good. Hey, hi everyone. So, okay, the session today is confidential AI. So, if you are trying to run machine learning models on Kubernetes and it actually needs some security on it. So, this session will help you understand to learn about data in use, and the data in use should be encrypted, right? So the agenda for this session mostly is to, basically encrypt data at use. Okay. So quick intro about me. I'm Siva. So I do systems. So I implement research at IISc. So yeah, you can talk me with about Linux and KTS. Yeah. So quick hand raise. So everyone here, whenever have you heard about confidential containers? Good. One. So anyone know about Kubernetes here? It's very obvious question that everyone knows. So the presentation here is to take you forward from Kubernetes to confidential containers. So yeah. You can go through this as just, what I'm going to cover right now. Basically, the problem that we have right now is during the data lifecycle process, data will be at rest. It's encrypted in databases. In transit, it will be encrypted with SSL certificates. And the problem that is data in use. Let's say you are running your LLM as said by the speaker before in your cloud platform. You don't know that your data is secure or it is protected. So the confidential containers provides that. So it will provide you to basically encrypt your data at runtime, and you will know that it is running on specific hardware in the cloud rack. So for optimization, cloud providers basically just run the workloads anywhere they want, but you want to run it on the specific hardware, so you can do it with this. And yeah, here also same. So this is mostly the hardware technology. We need specific kind of hardware to do this. So it's called trusted execution environments. So trusted execution environments is a place in CPU, okay, where it's very secure. Nobody from the outside can access that. So few hardware providers are Intel XGX, AMD SCV and others. So this TEs provides basically hardware isolation. So it doesn't run on the normal CPU or RAM. It has a specific location where the machine learning models run and data is secure at that place. And then memory encryption. We already talked about this, data in use. So during runtime, the data should be encrypted. That's what it provides. And the third thing is remote attestation. If you know, remote attestation is simply verifying from a place. Let's say your workload is running in a cloud. So you need to verify that whether it is running on a specific hardware that you mentioned or not. So that's remote attestation. Remotely verifying things is remote attestation. Yeah, if you know, if you learn about these three things in this session, that's all. My job is done. So the same, the confidential containers that I talked earlier is for the general software. For confidential, for AI workloads, we need these three. Like data in use should be good, and model IP. Like let's say a good company, their weights are very IP, like very secure. They want to protect it. They can use confidential containers to run it. And inferencing results. So basically, it's to secure things at hardware level. So we can do it with the with drivers on Linux, but if you want to do it on Kubernetes, we have a project called Coco, that's confidential containers. It's a CNCF project. So anyone know Coco? Basically, it's developed by Red Hat and people. So it actually provides all these three, like data at runtime. We can remotely verify whether our workloads are running in right places, and yeah. So yeah. Let's first understand what is enclave. Okay, I think this is a new term. I might sound like a geek, but it's not. Enclave is a is a specific part of CPU that runs programs where only authorized people can run. This is, there are two types of ways how we can run programs with enclaves. One is process level. Let's say you want to, what you basically want to do is you want to encrypt a specific process, you can do it. And if you want to encrypt whole the VM, like you can do it that as well. That's a confidential VM. This is a secure enclave, it's a process. So everyone knows this. This is a regular containers. It's a Kubernetes cluster, like it's a one of the node. It brings up 2 pods, that's all. But when coming to this confidential containers, there is slightly one thing that's different. It brings up the Kubernetes cluster that we use for the confidential containers brings up VMs. So basically it uses Kata. So whenever we launch a pod, it will create a VM. It will create a VM. So the workloads are separated like this. So yeah, it is provided by Kata containers. You can check out their repo. So that's good. And earlier with the Kata containers, these are not measured. These VMs are not measured. They are not the trusted zone of ours. So if you go to the confidential containers, it's same as Kata, but it provides a secure space to run our workloads. Yeah. And if we understand the threat model, if we run our workload in cloud, so these are all the roles that can access your data. Let's say you are in a healthcare organization or you are in finance or any government organization. You don't want to share your data because it's a national security issue. So what you can do is you can use this confidential computing and eliminate all these guys from seeing the data. It's only runs on the hardware and nobody has access to it. So how nobody has access to it? Because encryption is at place and only authorized personnel can decrypt it and see the data. So we don't know. Basically whenever we run an app on cloud, so these guys, data center employees, infrastructure software, these guys might see your data. That's the reason, that's a concern in data privacy. We as a technical people ignored from a lot of days, and now it's coming to mainstream that this needs to be taken care. That's why we have this project. Yeah, this is the architecture of this specific Coco tool that I'm talking about. So if you can see, this is your normal Kubernetes cluster. Okay, and this is the guy that keeps your keys, that's KBS. It verifies remotely that it's running on the correct hardware and then releases the key. Let's say this is your normal master node and this is the CVM, confidential VM. If it's not running on the confidential VM, it does not release the key, that's all. So it verifies, this guy attestation service verifies whether it's running on the CVM or not. Once it's running on the CVM, it will release the key. That's all. So this is how internally the communication between the Kubernetes worker node and the peer pod that we are seeing is done. So it will create a network namespace. You can check out this. This is, this is huge for this slide. You can check out after this talk. So basically what we have is, we have these components. This basically brings up a new VM as a pod on top of this Kubernetes cluster. You'll get around your head when I show the demo. Okay, it's a bit tricky than traditional way because in Kubernetes it's just a pod, it runs on the node, but here it's not. It creates a VM and adds it to the Kubernetes. Okay. So let's go for the demo. So basically what happens is it's just a YAML file. Whenever you submit the YAML, it will go to the scheduler and Kubernetes understands that it is not the normal pod and then it needs to bring up the CVM. So it will create a confidential virtual machine and bring our workloads in that virtual machine. And before bringing that, the images are encrypted, right? So the we don't use normal Docker images here. We use the encrypted images. Those encrypted images needs to be decrypted. For decryption, it needs to verify that whether it's running on the same hardware that we mentioned, either AMD CV or any other hardware. So it is verified in the attestation service. After the key is released, then the workload will come. Okay. So yeah, this is the flow. Let's say this is our pod VM, and inside we have encrypted model and application layer. So if we, as a Kubernetes administrator, we bring up the workload, and whenever we do that, it will do the attestation. So attestation is nothing but verifying it's running on the correct hardware. Once it verifies, we go to the third step. I mean, we need data obviously. For data also, it does the attestation and get the data inside. And after that, it will execute the program. So before, in the normal Kubernetes, it won't do all these steps. It's just run. Whenever you run your pod, it just turns into running mode. But not here, all these steps will happen. First it verifies, then decrypts, then runs. That's all. If you know for this talk, that's all. Okay. Yeah. So basically, this is everyone knows this, right? It's a deployment. If you know Kubernetes, you will know this, obviously. It's basically a YAML file. Okay. It creates a deployment. That's all. And the three things that we need to add is these three. This is the init data. Our workload needs to reach the key broker service, right? We need to get the key to decrypt. So basically, this has a base64 encoded data. Okay, it's basically config file to reach other workload. It will reach the other workload and get the key, and it run it on as a Kata remote. It's not. We are saying to Kubernetes that it's not a normal workload. It's just a confidential VM. So these three things needed in your any manifest. Like either you are writing manifest or Helm charts. This is all you need to run it as a confidential VM. So yeah, we can take a demo. I think. Oh, sorry. Basically, what I'm doing is this is my key. I used to encrypt my Docker image, and this is my init data. It tells my pod to where to go for the keys. Okay, and then this is the demo which I created for this demo specifically. I'm trying to run this ML original because it has my confidential information that I don't want to share. So basically, this has the dummy data, and I'm running this workload right now. It's same as earlier one. Like this is a YAML file. Okay, I'm running that YAML file right now. So, oh sorry. I'm actually running this manifest. Before that, let's check whether there are anything that's running with the ML encrypted. There's no pods running with that name. What I'm trying to do is I'm just applying that, and it create a deployment. Okay, and now it will create a CVM. It's a confidential VM in the Azure. I'll just show you this. This is a VM that created. So see, I am actually searching if I can stop here. So this is the VM that actually created. So whenever we submit a workload, it don't create a pod. It will create a VM. After that, it will create a pod. See, it's in creating stage. So even if you come and check the pod, the name of the pod and the VM that's launched is similar. See, it's SS9MF. So this guy Azure VM list, the VM name is also SS9MF. So it's created when I create a pod. So you got it right. So that's all. The pod will create a VM and it will run at a secure location. So if I'm not, yeah, let me come here. So these are the two services. One is the attestation service we talked about that verifies things. This guy will verify and then release the key. It's in still creating stage. Here you will see logs that it will verify. Yeah, just give it a second. Yeah, see, you can see that our pod reached here to verify whether it's running on the secure hardware or not, and after that in this tab it will release a key. If you can, yeah, I'll scroll here. See, you can see this. It's a request. That's the key that I used to encrypt my image. In the earlier I showed that key. So that key is released. So it will decrypt now. Just a second. Yeah. And once the key is released, now you can see the pod is being created. The key got released, and basically this trustee will verify based on the sequence of information. Like when we build iOS image, it has a hashes, so chain of hashes. Those hashes will be verified by this trustee. Now you can see that the pod is in running state. So everything is secure from end to end, like where we run and the images are encrypted, and the hardware that we are running, and the data is at data is also at encryption during runtime. So yeah, the other techniques that you can also try like this is homomorphic encryption, secure multi-party computing, and federated learning. So these are the extensions, or you can think alternatives of this what I showed. So federated learning, everyone might know, like it's training models at edges and sending the weights to the server. So the models will be trained here and weights will be sent here. And this secure multi-party computing is where people collaborate and come together and solve a problem. Let's say in healthcare, people don't want to share data. So what they can do is they can come together at one compute, like this is secure compute, share data, share their models, and train everything here and leave. Nobody knows anything. Let's say this data guy don't want to share data to model guy don't want to share their weights to data guys. So here like this, people will collaborate. And yeah, I think we came to end of the session. So basically, if you just understand this, that's all. Like the whole point of this talk is data at use should be encrypted, and then that's provided by Coco, and you can use it on top of Kubernetes as well. That's all. If you understand these 3 points, that's all. And going forward, it can be implemented with Kubeflow, and LLMs can also run on the same workloads. Like you can just change the Docker image, okay, and it will run basically on the secure hardware. And if you want to get involved with this community, Coco, you can scan this. And if you don't have the hardware that I mentioned, you can set up without hardware as well. They also provide simulations. You can try it in local. So I'll wait a minute here, because these will point you to right direction to set up this.
Hello.
Yeah.
Question for you.